Hello, and welcome to the Certified Ethical Hacker Study Guide. In this video, we will discuss Chapters 2.5, the Octal Numbering System. Please like, subscribe, and hit the notification bell. Now, let's dance our way into the first topic. Reviewing the Octal Numbering System. An octal number is a base 8 number, so it's written by using these 8 values, 0, 1, 2, 3, 4, 5, 6, and 7. Because you're a binary expert now, it's easy to see how binary converts to octal. An octal digit can be represented with only 3 bits because the largest digit in octal is 7. The number 7 is written as 000000111 or 111 if you drop the leading zeros. The binary equivalent of the octal number 5 is then 101. To see how this concept relates to network security, take a look at Unix permissions again. Octal numbering is used to express the following permissions on a directory or file: owner permissions, group permissions, and other permissions. Setting the permission RWXERWXRWX for a directory means that the owner of the directory, members of a group, and everyone else or other have read, write, and execute permissions for this directory. Because each category has 3 unique permissions, and because each permission can be expressed as true or false, or on or off, 3 bits are used. You don't need all 8 bits because 3 bits, RRWX, are enough. Recall from binary numbering that 0 is counted as a number. So with 3 bits, there are 8 possible occurrences: 000, 001, 010, 011, 100, 101, 110, and 111. Using octal numbering, 001 indicates that the execute permission is granted, 010 indicates that the write permission is granted but not read and execute, and so on. The octal number 7 indicates all ones, or 111, which is 1 plus 2 plus 4. So, in Unix and Linux systems, 777, in binary 11111111, indicates that the owner, group, and other have all permissions, RWX, to a file or directory. File name, directory that owner group, other can WX, permissions, Drux RWX, owner RWX, group RWX, description, directory with full permissions for owner, group, and other. File name, executable program, permissions, RDXRXRX, owner, RWX, group, RX, description, executable program that owner has full permissions over, group and other can execute. These are just a couple examples of permissions. Now let's crash into the next topic. Changing permissions with the chmod command. In Unix and Linux systems, the chmod command allows you to alter the permissions of files and directories. This is useful if you need to provide more or less permissions to a file or directory for security purposes. You can use chmod to change permissions in 2 main ways. One way is to provide the permissions as an octal number. For example, to change the permissions of the file hello.txt so that the owner, group, and other members have full read, write, and execute permissions, enter the following command: chmod 777 hello.txt. Remember that 7 octal in binary is 111, which means the R, W, and X bits are all enabled, giving read, write, and execute permissions. The first 7 in 777 gives the owner full RWX permissions. The second 7 gives the group full RWX permissions. And the final 7 gives other full RWX permissions. If you want to change permissions so that other users have no permission at all for the file hello.txt, use the following command: chmod 770 hello.txt. If you want to change permissions so that the owner has read and write permissions, the group has read permissions, and other has execute permissions, use the following command: chmod 641 hello.txt. Now let's slide into the next topic. Besides providing a full 3-digit octal permission number, chmod allows you to target specific permission sets, owner, group, or other, and turn individual read, write, or execute permissions on or off. To do this, you need to specify who you are setting permissions for, what change are you making, adding or removing the permission, and which permission you are setting. You may find this targeted approach more convenient. The who values you can use are the following: U, user, meaning the owner of the file; G, group, meaning members of the group the file belongs to; O, others, meaning people not governed by the U and G permissions; A, all meaning all of the above, the what, minus sign to remove the permission, plus sign to grant the permission, equals sign to set a permission and remove others. The which values you can use are the following: R, read permission, W, write permission, X, execute permission. For example, if you want to change the permissions for the file, hello.txt so that the other users could have read permissions again, use the following command, chmod plus r hello.txt. To take away execution permission from group members, use following command, chmod g, x hello.txt. If you find this video useful, please hit the like button, leave a comment and subscribe to the channel. If you are unable to do that, you will need to log in. Creating a YouTube account is free and takes less than a minute. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. See you on the next one.